that most of us are kind of on the 3 or 4 side of things. There's definitely some 1s and 2s, and there's some 5s, which those of you that are 5s, you're going to love everything about today's lesson. Those that are 1 and 2s, I hope that we can take those 1s and 2s and turn them into at least a 3, right? I want you to be neutral or okay with it. I want you to start to be able to conceptualize the idea of scope, and then we're going to get into some deeper stuff. So today's lesson is maybe one of the most important lessons of this first unit. The things we're going to learn today are things that you are going to use throughout the rest of your time at Lambda, and if you stay JavaScript developers throughout the rest of your career, because this closures and callbacks, these kind of things are incredibly important. I want to preface this all by saying that this stuff is not easy, right? This stuff is very difficult. If you do not get it the first time, that's okay, right? This is fine. If you're like completely freaking out right now, take a deep breath. We're good. It's okay to not fully understand this. In fact, like I tell everyone, I would say a good percentage of professional developers do not fully understand closure scope or accurately. We use it every day. It's kind of one of those things that you just get used to using, but I would like you to be one of those developers that understands it, or at least has a good idea of what it goes, of what it consists of, and also be able to speak about it, right? But if you don't get it the first time, that's why we're here. Practice, practice, practice. That's all we do. All right. Let me share my screen. All right, we have this very filled out CodePen. CodePen today is going to be a little funky because we're just writing JavaScript. We're not using the CSS or HTML portions of CodePen, so I'm going to be writing in it. So first thing we're going to talk about is lexical scope and closures. Before I get started, I would like your opinions. Also, one quick thing, I don't allow memes during the or GIFs during the lecture. So, well, that's the last one, but it's all good. Just because I want to be able to keep the clutter down because this is going to get chaotic. So, those of you, let's think. This is a tough one. I want you to tell me what you think a closure is. This could be like a novel written about this. No, let's just jump into it real quick. So when I talk, let's do this. When I talk about global scope, what scope am I talking about? What am I talking about in the browser? Just type it into Slack. Freeform. The whole thing. Window object. Oh, yeah. Scope, not the function. Global object in Node, 100%. All of it, right? Everything. Okay, the entire ecosystem that we are living in currently, right, in our browser. So when I talk about global scope, ultimately, in the browser, I'm talking about the window. Okay, but it could be, it's called global in Node. All right. So it's the window in our browser. So let's go check out the window. I'm going to open this up. How do I find the window? Oh, it might be full of code. I haven't saved it yet. So all I need to do is type window, okay? The window, and it's kind of funny because we're asking for the window within the window, all right? But the window is everything. The window is everything, okay? It is every single function definition. It is our object. It is our arrays. It is everything. And so it's really kind of a good time to start wrapping your head around this, that ultimately, when we write JavaScript, ultimately in the browser, the window contains everything. The definitions for our language, every single thing happens in the window, all right? And so when we are in the global scope, we have access to everything. And we'll see in a moment, we're always in the global scope. So we have access to everything at all times. So let's go see location. Check out location. Location tells us where we are in our location, right? All of our, there it is, okay? Let's go see if we can find some prototypes. There we go. Let's find, that's a good one, array. Array, look at that, boom, there's our array definition. We can create arrays because this is on the window, okay? So when we talk about global scope, this is what we're talking about. Make text bigger in which side? On this side? I can do that. So when we're talking about global scope, we're talking about the window, okay? Cool. So let's jump in and let's talk about functions. So we know that functions have their own scope, right? Call it function scope. Okay. And function scope is kind of a tricky thing. So when I write a function, oh man, if I can spell today. What is the scope in here is special, right? It is going to be available only to this function, right? Is this function able to reach out and get something from the global scope? It looks like Olive, almost, I think, I don't want to get there yet. Oh, wait. Okay, yes. So the answer is yes. A function can reach out and get access to any scope outside of it, okay? Can the global scope, if I created a variable here, let new var, let's put my name, can I access that new var from outside of that function scope? Nope, absolutely not. My best analogy for functions are that they are like religious cults, and they let anyone in, but you can never get out of it. Or it's like a gang, a street gang. You can get in, but it's really, really difficult to get out, right? So we have this ability in the function. If I type in outside var equal, I'll just go 1, 2, 3. I can access this is good, right? Good to go. I can access anything outside of this function, anything outside of the scope of this function, but I cannot access anything in this function from outside. What's the only way I can access something from inside of a function? So I see most of you will call the function, first of all. Thank you, Melissa. It didn't show your name for a minute. Call the function, and then I'm going to return something from that function, right? Cool. That's just a quick reminder of function scope, right? If I say return new var, and then I call my function, I'm going to go newer var, then I have access to that now. And I can run this, and we should see both of those appear on my screen, right? So there we go, inside the function. Let's go inside the function. And let's say outside the function. Run that again. And then we see inside the function and outside the function. Okay, so we get that 1, 2, 3. So we can access things from outside of the function. And then once we return something, we can access that outside of the function as well. If I did not return this, and I said new var, I would get an error, right? Oh, it's not even going to do it for me. It's going to error out. New var is not defined, right? Remember, I can't access. Can I do this? Can I access new var if I call that function and I return to new var? var does not. Nothing has the ability to break out of function scope. The only thing that has the ability to break out of function scope is the return statement. Very important to understand that. It's a cult. Okay, so no, I can't, right? When I call this, I'm not necessarily returning this exact variable. I'm returning what that variable equals. So that's a little kind of different. I'm not returning that exact variable, right? So I can assign it to a new variable and call that, but I don't actually ever get access to that specific variable, just what it points to. Little weird. Let's not focus on that. Let's just focus on the ability to break things out. All right. So I'm going to start writing. I'm going to keep that on there for you. I'm going to start talking about something called lexical scope. And it's important for us to understand what lexical scope is. It's important for us to understand what scope we are currently in. So all lexical scope means is it describes the scope where something was created. So the lexical scope of this var is this function's scope, okay? So that's the lexical scope of this var. It describes where the scope of where it's created. The lexical scope of this var is the global, all right? So it's important for us to start to see and start to visualize the scope where the value was created, okay? So I'm going to start creating this little kingdom, the world. The world, outside of this, let's go, where our kingdom exists. Okay. Where does this kingdom exist right now? We're right here. We're floating in space right here. This is the world. Yeah, it's our global scope, right? It's the window, all right? So we're going to call this our global. And it's where our kingdom exists right here. Just this, the rest of the world, right? I should do this with a cult, but I can't think of like the proper things to do it with. So we're going to call this a kingdom, a walled kingdom, right? Kind of similar, although, yeah. You can't get into one, but you can get out. But we're going to use this anyways. So let's call this function kingdom, okay? Our entire kingdom lies in this function. We are going to have a queen. What should our queen's name be? I knew someone always says Cersei. Oh, I want Beyonce, actually. I never do Beyonce. Queen Bee. All right. Okay, so in this, we have a queen, all right? And let's console log our queen. And I'm going to use something called a debugger. Debugger allows us to stop our code from running at a certain point only when our dev tools are open. Okay. And so now I'm going to call this kingdom. And let's go like, yeah, we're not going to worry about the global. We know that we have access outside of the kingdom to everything, right? So I'm going to call the kingdom right now. I'm going to run it. And what should we expect to see on the screen? Well, we should expect to see our console log, our queen's name. And let's go check something out real quick. This is a really cool way of visualizing our scope. When we use the debugger, it allows us to jump into our code, and it tells us the scope that we are currently in. So what is the scope we're currently in with this debugger? It is a breakpoint, 100%, Michael. Yeah, we're in this kingdom's function scope. Are we also currently in the global scope? Yeah, we are in the global scope, right? Because everything lives in global scope, right? So no matter what, but outside of here, if I did debugger here, would I be inside of that kingdom scope? No, I wouldn't, right? I would only be floating in space. This is like the wild lands outside of the kingdom with roaming bands of thieves and weird gangs, right? But in the kingdom, I'm in the kingdom scope, but I'm also in the global scope, okay? So we can actually see that in our browser. When we use that debugger, we get this thing right here called scope. And it tells us our local scope. So our local scope is going to be the function scope, where we currently are at, right? And we see that we have a queen, Beyonce, but that also we have access to global scope, right? And there's all of our global scope. And if I added something, let's go, so let's do something like really like, call it something really lame so that we can see it. Let's go forward, resume, I'll run it again. Okay, we're back in there. And let's go, oh, where's it at? Come on. Oh, it did not like that. Ah. Anyways, it's in there somewhere. that Z is in there. But we are a part of that global scope as well, okay? John, is that a DOS racist quote? It's pretty hilarious. So the kingdom, we know we have a queen, and we have this the scope about it. We have this internal scope, right? That's our local scope. Okay. Let's take this one step further. All right. Let's say what are inside of kingdoms? Let's say a city. Okay. Function is a city. So look at this. I'm creating a new function within this function. I want to pause for a moment. If anyone has any questions or issues with the fact that I'm creating a new function within another function. If there are any questions about this, please bring them up. I see a lot of typing, so I'm going to give it a moment. Okay. Ooh, Rocky. This is going to be done a lot in real-world scenarios. In fact, I'm going to show you one place it's already done. Before I move any further, I just want you to be comfortable with the fact that inside of this function, I can do whatever I want. I can create and write all of the JavaScript I want, and I have this little walled kingdom, walled garden in here, and that the scope doesn't know anything outside of it's contained within itself, right? So let me say that we've already been doing this. We just have, or the people that have programmed our language and programmed our browser have kind of abstracted this step away from us. But I want you to really think about the fact that the window is a function. And everything that we write and have written, all of the JavaScript we've written has been inside of another function called window. Okay, this is actually, don't do this, it'll break everything. But I want you to understand that everything we've already done has already been inside of a function. Okay, so the fact that we can write a function within another function is okay, right? And we can actually do anything we want inside of a function. No callbacks yet. We're just on closures for right now. Okay, so I just want to make sure that's clear that like I can create functions and call them and do other things inside of other functions. All right. So let's do this. A city has a mayor. What's our mayor's name? Piddles. All right, Mayor Piddles. Oh, I would have liked Freddie Mercury more, but also I don't know if what Piddles is, so I hope it's not like anything like weird or offensive. Sure. Mayor McNair face. Oh, that would have been the best. Okay, so let's come in here. I'm going to console log our mayor. Let's go. We're going to say, we're going to do this, actually. And then I'm going to say, in here, mayor. Got to use backticks. Anyone have an issue with me using string template literals here? Okay, cool. Those of you that are not familiar with string template literals, these are backticks. These are not single quotes, and it allows us to inject variables directly into our string. They're amazing. We don't have to concatenate strings using pluses and weird things like that anymore. So using the backticks, I can then use this little syntax here, the $ and the curly brackets, and I can just put variables inside of there, and it will take whatever that variable is and inject it into that string. Yes, backticks replace the quote marks. Okay. So our debugger down, and then we also have to call this. Ooh, here's a good question. Can I call this right here? All right, I think that we're all on the same page right here. No, I can't call this right here, right? Because it exists inside of this kingdom function's scope, right? This function exists inside of a scope of another function. And unless I return, yeah, I could return city if I wanted to, and then taken that and then assign it to a variable, then called it again. But I can't access this function outside of that kingdom scope, right? So let's call it inside of here. Can I do this? Yes, I can. Okay, so let's walk through what's going to happen. This is going to be created. We're going to call it. This function will be created. We're going to see long live Beyonce. We're going to have our debugger stop where we are right here. And then it's going to call this inside of there. Okay, so then it's going to come in here, and we're going to get our mayor, and then we'll get our debugger, and let's go check out our scope. All right, now let's go forward. Let's run it. And let's check it out. All right, so we are in the kingdom scope right here. This is so cool because it gives you like what the variables equal at that exact moment. If we change our variables anywhere in here, it'll change it for us there. So let's see, we have our local scope. And cool, we've added a new thing to our local scope, which is that city, and it's a function, okay? We also still have our Queen Beyonce, and we have that city now as a function. And, ooh, okay, we'll go through that in a minute. So let's move one step forward. And now we have a couple of different things. We have access to our, inside of our city function, we have our mayor. We should, where's our, our scope should be here as well with our kingdom. But we have our mayor. We have access to the global scope still. Do we have access to this kingdom scope? We do. I don't know why it's not showing it right here, because it normally does, but we do have access to the kingdom scope. So within the city, we have access to the kingdom scope and the global scope. Let's now come in here, and what if I said, I'm just going to console log queen, right? What if I said console log queen right now? Is this going to work, or is it will it return an error? Oh yeah, okay, there we go. Yeah, it's gonna work, right? It should work, because we know that if we are in a function, we have access to the scope created outside of that function, okay? So this is what's called a closure, all right? And honestly, you can go onto the internet and you can read 100 different blog posts, and you'll read 100 different ideas of what a closure is, but it all boils down to this, okay? The fact is that I can call a city over and over and over again. I can even, I don't want to get too complicated right now, I can return city, and it's still going to have access to that queen. Closure means that we have created scope that remembers where it's created it, okay? So it allows us to create these functions that I want to say remember its scope. Remember the scope that it was created in. So this is going to be a closure. The kingdom is also a closure, right? Because it does have access to that global scope. I can call it from anywhere, and it still has access to that global scope. If I return this function, I can call it, and it still has access to this kingdom scope. Okay. Let's see. Could you create a variable outside of kingdom and access it in city? Yeah, sure. And then come in here and console log it. Will this work? If it's spelled right, make sure it's spelled right. Yeah, it's going to work, right? Because the city has access to the global scope still, right? So this is our band of thieves that just roam the forest outside of the kingdom. We still have access, so we can still see them, right? We still know what that is. And when we have access, well, I mean, we have access to that outside kingdom in kingdom as well, right? We also have access to whatever's in the kingdom. But can I do this? I can't, right? Because we cannot reach in and get anything out of this scope of this function. We have walled this city off within the kingdom, okay? It's its own private little, we can consider this like a gated community, right? So it's our walled city within our walled kingdom. So outside kingdom has no idea what's going on in there, right? But we can see out. The kingdom really can't see in, the rest of the kingdom can't see into the city, but the city can see out to the rest of the kingdom. Okay. So let's go deeper. We'll get scopeception. Let's call this our gated community. And we're going to have an HOA president. Who's our HOA president? Weird Al, thankfully. That would be the best community to live in, by the way. Or annoying, depending on who you are. All right, so let's just go through this once again. Do a little backtick action, actually. President. And we'll debugger this. And we will call our gated community within our city. Can I call gated community in the kingdom? Ooh, I'm getting like yes, no, yes, no, yes, no, yes, no, yes, no. Okay, let's walk through it and let's see. I can call kingdom in the global scope because the kingdom was created on the global scope, right? Remember, the global scope is essentially just this. Okay, and I can call it there, right? Can I call city on the global scope? I can't, right? Because we cannot reach inside of this function and get any data out unless we return it, right? So that's pretty simple. We already understand that. So I have to call city within the kingdom. So I have city. The gated community is in the city, right? So this city has its own scope. This belongs to the city. Okay, everything inside of here belongs to the city. So now can I call gated community in the kingdom? I cannot, because the kingdom has no idea that this gated community function exists. Just like the window has no idea that the city function exists, okay? But, and this is where it starts to get a little tricky, and this is as deep as we're gonna go. We have to remember the scope that we're created in, okay? So, city can only be called in kingdom, right? It's the only place it can be called because that's the scope it's in. There's nothing outside of the kingdom can access the city. All right, nothing outside of that city can access the gated community because it's in the city. Okay. So I have to call it inside of city. And it's a little tricky because I know a lot of you aren't used to seeing nested functions like this, but this does happen. And it gets a lot crazier. The things that closures are really meant for is doing a bunch of stuff, maintaining memory of the scope, returning that function to be used elsewhere, and allowing us to still have memory of that scope elsewhere. Oop, no drawing on the screen, please. So what would happen if you called city and gated community? We would get a recursive call. You're allowed to, right? City is just another variable. I can call that in gated community, but since I call gated community, it's going to go city, gated community, city, gated community, and we'll get a Stack Overflow, or worse, we'll get an infinite loop, and it will crash our browser. So you can do that, but don't do it. All right. So let's just walk through this and see what we got going on. Let's run it. First things first, we are going to stop. Ooh, console log error. Oh, yeah, we can't do that. We got an error, of course. All right, now let's run it. Okay, first things first, we stop in our kingdom. Kingdom gets called first, right? So we stop in our kingdom. We see that we have access to the city, which is a function. Notice you do not see gated community in here, right? So that means we are not allowed to have access to that. Oh, where's the typo at? Gated. All right, let's move all the way through it. Don't want to get hung up on anything with that. Where's our debugger at? Now it's not stopping for some reason. It's because I pressed that 100 times. Oh, no. All right. Give me 1 second to clear this up. Actually, while I clear this up, let's take a break. We're at break time right now. 5-minute time for kids. Let's take 5. And if you have any other questions, throw them into Slack. I'm going to get this cleaned up, and we will get back on track. Come on back. We'll keep going. I have been working on this for 5 minutes, and I am yet to figure out what my issue is. Pause on exceptions. Activate breakpoints. Okay. Still not getting our breakpoints. What's going on? Everything's working. Huh. Okay. We're not going to do pause on exceptions. Let's go to that pen. There we go. We'll just add our own debuggers in. It still didn't work. Okay, our debugger is not working right now. I'm not 100% sure why, but I did refresh the browser. And it's not working on my sample code either. But we got to see that, right? We already saw that. Let's kind of go back through this and talk about it once again. I know. I would much rather use something else, but we're using CodePen now, and I don't want to start over on anything else. We have our, also, my bad, I did not fork it before. The joys of, here's our forked code. This is for us. Let's see. We are outside the kingdom here, right? This scope, the lexical scope of this is our global scope, okay? That is what lexical scope means. So someone asks, is lexical scope the same as closure, or how does it differ? Lexical scope just is a term that we use to describe the scope where something was created. So the lexical scope of this variable is the global, or the window. Okay, the lexical scope of this variable is kingdom, right? Lexical scope of this variable is city, and this is gated community. Okay, a closure is, this is not part of my official notes, but I really want to show you this. A closure works really well when we can do something like this. Don't let this confuse you. I just want to show you something that we can do and why closures are cool and why we learn about them. Let's go. This is now the city function. Okay, so we're going to return that city function. So I'm just going to copy that. So can I call this function, first of all, for all of you? I can. What should we see console logged when I call this function? We're going to see something console logged. We're going to see long live the queen when I call that kingdom function. But what happens when we call the city function? Are we going to be able to access queen? We can, even though we're calling it in the global scope. I can still access queen. I can still access outside kingdom. I can. It's probably going to run now. Look at that. I got it all. no errors, nothing happened. That's a closure, okay? The closure gave us access to that. It remembers where it was created, right? It remembers the scope it has been created in. And so it still has access to that, even though now it's outside of it. And look at that. We just busted that wall down. We tore the city wall down. We tore the kingdom wall down. We busted everyone out, right? Because of closure. So closure allows us to, and this is more advanced than you're going to need to know for today. Closure allows us to create functions with, I don't necessarily want to say it is this, but this is the best explanation, with a memory of where it was created, okay? So it is, it allows us to, maintain this memory of where this function was created, and still have access to all that stuff. Okay, so I mean, I can do this too. Return gated community, and then I can say let new gated from fun. And now if I say that, same thing. It's now has access to, think about this, the gated community has access to this scope and this scope, all right? So we could have created this a long time ago and then busted it out and held on to this variable and held on to it for a long time until we needed to use it. All of this could have gone by the wayside. Our memory management within our browser could have garbage collected all this stuff, but gated community still remembers. Gated community will always remember. If you don't return, yeah, I mean, you could, if you call it, it'll have that memory. But yeah, if it don't return, then you're not returning that function. So that's what a closure is. It's a really kind of overly conceptual idea. And like I said, you'll read 100 blog posts and there will be 100 different ideas of ways of describing what a closure is. I think this is a good example, and it lets you start to piece it together and start to understand. The one things we want to always remember about functions and about creating variables and about creating data inside of functions is we want to be able to recognize the lexical scope of that value. Right? We want to be able to recognize the lexical scope of queen bee here, right? We want to say yes, I can access queen bee within this scope. That is the scope we have. I can access mayor petals within this scope, right? You want to just start to understand the scope of your functions. Yep. Yeah, we just smuggled everyone out, right? So that's closure. Right now, do you have any questions on that? Because I know there's probably a ton of questions, but that's the basics of closure right there. But I do want to jump into this next stuff because the next stuff is really important too. I don't want Kyle, and I don't want anyone to think of memory, because when we say memory, when we talk about computers and browsers, it means a very specific thing. I want to say that function remembers the scope it was in. Okay, it is not. Don't think of it as any kind of pointers or anything like that in memory. There is a lot to do with that stuff, but we're not getting into that today. That's outside of the scope of this lecture. Yeah, let's just say that the function remembers the scope that it was created in, okay? Can I just do this? Yeah, let's see. Can I do this? It's a question for everyone. Can I just call city in the global scope? I can't, right? Because city is a part of the kingdom scope, and I can't reach in and grab anything. If I returned that from the kingdom, then I could do that, right? So no, I can't just call city on here. Okay. Like I said, this part of like returning all the functions and seeing that new value, it's a little bit outside of the scope of this lecture even. Oh, outside the scope of this lecture. But I wanted to show you why closure and closure scope is important. Is it allows us access to the scope it was created in, okay? So I am going to move on because we got a lot of content to cover today, and I want to make sure that we are able to do that. So let's do this. You know about functions, obviously, hopefully. We're going to say new function. And we're not going to give it anything. Yeah, maybe we'll give it a name. And then we're just going to console log. This is my name. And I'm going to use the old school way of doing it. Okay. I hope that nobody has an issue with this right here. I want to talk about functions as they are. You already know a little bit about hoisting, right? When I use the function keyword, what happens? Is the whole function hoisted to the top, or is just the name? Yeah, I can call it. The whole function is when I have use the function keyword. Okay. Oh, undefined. Oh, yeah, because I didn't put his name in there. There we go. Much better. Okay. So look at this. Can I do this? Can I do that? Sure, why not, right? I can assign a new variable to whatever that function is, okay? I can then pass this variable around, you know, like we do a bunch of stuff, right? And then maybe later on I want to say, and call it. Yeah, it's still going to work. Oh, we got undefined again because I didn't do it. Jason, you're next. I'm used to writing JSON. All right, there we go. Yeah. So this just goes to show that we can pass around functions like we would any other variable. Okay. The same way we can do this. Let I am 42, and then later on we can say, or let's do this. I'm sorry, I'm like thinking and going. And then we can say let new num equal I know, right? We can pass around functions like we would pass around any variable. We can do this whenever we want. So now let's come up with this other idea. And let's say my name equals, first one's on there is Julie. Let's say my name is equal to Julie. Can I take that variable and pass it into a function? Can I do this? Yep, I sure can, right? I can just take a variable and pass it around like I would any other thing. Okay, I can run it. And then we'll see, yeah, it works just the way we thought it was going to work, right? So that leads us to think, can I Samir, you're up next. Can I take a function and pass it as an argument to another function? Yeah. And look, I can even do this right now. Another new function. And if I call it, what's going to happen? What am I going to be passing in if I call that? Yeah, I'm going to return Samir. So let's clear that. We're going to see that we should just get, this is my name, Samir. Right? Look, I just passed a function. And did I actually pass a function in right here? I didn't. I just passed that string in. So that's what happens when I called that function, is I just returned that string to this. But if I don't call that function, then I pass the entire function definition in. And I can say, and then I can call it whenever I want. Okay, I'll run that, and we should get the same thing. So this function is called a callback. This function being passed as a as an argument to another function is called a callback. Okay. All this means is that this is a function. And I'm going to rename this. All it means is that I'm giving another function here a function to call whenever it sees fit. Okay. So just like I could pass a string in right here and use that string whenever I wanted to, I can also pass a function in and use that function whenever I wanted to. Okay, I can call that function 1,000 times if I want to, or never. All right. Can anyone tell me what another function here is called? That's such a horrible name. Oh, we're gonna call it new function, right? Oh, I kind of want to lose that. Can anyone tell me what new function here is called? The name of this. Yeah, this is called a higher order function. So a higher order function or HOF is a function that takes another function as an argument. Okay, that's a definition of a higher order function. That's all a higher order function is. It's a function that takes another function as an argument. So I'm going to call this higher order function. Okay. Ooh, or there. So this is called a higher order function. Do I have to call it higher order function? No, I call it whatever I want, right? This is not going to ever be called higher order function. Okay, so this is the higher order function. Right? What is this called? Yeah, this is the callback function. And that is a function passed as an argument to be called the higher order function at a different time. Okay. So that's the makeup of a higher order function and a callback. A callback is simply, very simply, it's just a function, right? It's all it is. And we pass it into a higher order function so that the higher order function can call that function, the other function at any other time. I know I've said the word function about 1,000 times in the last 2 minutes, but I just want to get, and we can, I'm just going to call this a callback from now on. Okay. Someone asks, John, can you only use callback or CB, or can you use any name? I can use any name. But what you're going to see as convention is CB or callback. Okay. And why do you think that is? Why do you think that we would see CB or callback used as our parameter in that higher order function? Readability, semantic. We know it's a callback, right? We know for a fact that this is a function. When we see this, we're like, oh, it's a callback function. We know it, right? If I see like, right, is this still going to work? Yeah, this will work. Do I know what the heck this does? Do I even know that it's a function? Have no idea, right? I don't unless I wrote it specifically. And we don't write code for just ourselves. We write code for ourselves, for other developers, for future us. Trust me when I say, if you give this callback function an awful name, and 3 months down the line, you come back to your code, you're going to have no idea what that is. Okay? So just throw down CB. Or, I mean, you can even put like returns name, right? Like, okay, I can kind of get what that does. It returns something, so it's obviously a function. It's a name. This isn't the best name for it, but we kind of get what it does, right? For now, let's just use CB so that we know that it's a function and we can call that function. So right now, are there any questions regarding higher order functions or callback functions? Do you have to call the function in the higher order function? Nope, you don't have to do anything, right? The higher order function, it might be like, if, it could be conditional. Like if something is this way, then call the callback. If not, then do it something else, right? Devin, I want to say we'll be learning about promises not next week, the week after. And so you don't really have to worry about if you're referring to what's known as callback hell. We don't really have to worry about that anymore. But yes. Oh yeah. Oh, I'll show you how parameters are used in callback function for sure. Actually, right now. Are there any other questions though? As you're typing your questions, I'm going to start typing something out. Let's go function add. Let's actually just, yeah, let's do add. Num1, num2. Return. The most practical purpose for a callback is an asynchronous action, but we're not getting there today. And we're also going to see some very practical purposes for callbacks here in just about 20 minutes. And we're going to see one right now. Callbacks are going to be your life. Trust me when I say that. In JavaScript, they are everything. All right, so What do I expect to be printed to the screen when I type this in? 3, right? Yeah, it's really simple. It's a super simple function that just adds 2 numbers together. So what we're going to do and let's just do this. We'll go boom, boom, boom. Instead of add, we're going to go subtract. We're going to go multiply. And let's do a divide. All right. Are any of these odd looking to you? Or do you have any questions about any of these functions that I have written here? These are pretty simple mathematical. It's going to take 2 numbers. Each of these are going to take 2 numbers, and they're going to return, the sum, the product, whatever we're doing here, the difference. I forgot what it's called, divide, but it's going to return that number, those 2 numbers, put into some sort of math operator, right? Quotient, I knew, dang it. So yeah, it's just a simple math operator. So what we can do, actually, is now let's build a calculator. Let's think about what this calculator needs to take in. What parameters should a calculator take in? Numbers, right? We're going to do a simple calculator. We're going to give it a number, and let's just call this first num and second num. And then what else should it take in? I see it already on the screen. Yeah, the operator we want to put those numbers into, right? So when I get on my calculator and I press like 1 + 1, what am I doing? I'm putting 2 numbers in and an operator, right? That's what I'm doing. So let's call this operator. And what is this operator going to be? Yeah, this is going to be a callback function, right? So I'm going to do this, operator callback. Okay. So I have this first number, I have the second number, and I have an operator callback. All right. How do I plug all of these into each other in order to get the number I want out? First of all, I'm going to return something, right? I want to get something out of here. And then what's next? What am I going to put in here next? Yeah, I'm going to need to use this callback, right? I have to use it. Okay. What is this? Like beyond callback, what is it? What is this going to be? It's a function, right? How do I call a function? Yep, I'm going to use open and close brackets. And which of these functions is it going to be? I like it. And first of all, it's going to be any or all of them or none of them. Maybe we add some functions down the road that's like cosine and tangent and square root, right? It could be any of these. Does the calculator know which of these functions the operator is? Does it care? It will never know, and it will never care, right, what it is, okay? All it knows is that it's a callback, and it's going to take two numbers. That's all it knows, all right? That's it, okay? So we see a pattern here with all of these callback functions. The pattern is that we give it two numbers. We should, since these are labeled, we should maintain the order of these numbers. So I'm going to pass in first num and second num. All right. So the calculator is going to take a number in. It's going to take a second number in, and it's going to take an operator. It's going to return those two numbers placed into that operator, and whatever that gives us back. Any questions on this right now? We haven't used it yet. Honey, yeah, calculator, don't care. See a lot of typing, so I'm going to give it a minute. Oh, any questions? Do you have to create a function for the operator callback? Yeah, we will do that. We haven't called calculator yet, right? Yeah, so let's see. What is calculator? What type of function is calculator? Yeah, calculator is a higher order function, right? We know that it's a higher order function because it takes a function as an argument, okay? So we know that it is. So let's call it. All right, I want two numbers, just one number from each person, and nothing, well, you can do whatever you want, insane. 13 and 74, yeah, we'll do that, 13, 74. So I'm gonna pass two numbers in, and then I'm gonna pass in an operator. If I wanna say multiply, do I do this? We don't. We want to let the higher order function call it, right? So we just pass it in as the value of that function, right? So let's see what we get. Run it. And we get our calculator is working. Let's change it up. Let's say add. All right, so what should we expect to get back if we take these two numbers and we pass in the add function? Should get 87, hopefully. There we go. And we're going to go subtract. Should get negative 61, right? Oh, we got to, let's see. Oh, it's not called subtract, it's called sub. I'm going to change that to subtract because that makes more sense. And there we go. And divide is going to be something crazy. I don't even want to do that in my head. There we go. So look at this. We are using a single higher order function. We're passing the same two numbers into it. And the only thing we're changing is that operator. And that operator is doing its magic. All right. So now we can do whatever we want, right? We can, you know, if we wanted to do a square root, that would be difficult. No, we're not going to do a square root because we only have two numbers or a square. But we can see that we could create over time. You can create a calculator that takes an infinite amount of numbers in a single operator if you'd like to. You can create a calculator that does all kinds of things. But the basic fact of the matter is is that we are giving it two numbers and a function. All right, and that callback function is going to be called with those two numbers in there. All right, the big takeaways from this are that we can pass functions in the same exact way that we pass any other data type in. Primitive, we can pass objects and arrays into functions, and we can pass functions into functions. All right. When we use a callback, we allow the higher order function to call that callback where it deems necessary. All right. So just keep that in mind. We never call the callback. Well, I don't want to say never. Never is too strong a word. We don't, for now, call the callback when we pass it in as an argument. Yep. Why exactly do we not have to do add when doing the callback? So great question, Connor. At which point? Are you saying in 97 or at 94? Okay, so if I were to say divide and call it, what would I get? What would happen here? I would get 13 as first number, 74 as second number, and then I would get undefined divided by undefined, not a number, as the third number. And then this wouldn't be a function, so we would get an error. And actually, I'm going to have to open up my console to see that error. It's going to say operator callback is not a function. And we can even do this. And then run it again. And we'll get not a number because it's undefined divided by undefined, so it's not a number, and then operator callback is not a function. We need to pass a function in order to call a function, right? What? Where am I at? Yeah. Okay, there we go. Thank you. Now we'll see that our operator callback is the function divide, not called. It's the whole function passed to us. So then we can call it whatever we want. We just renamed it. Remember up here when we renamed that function there? That's all we're doing here, is we're just renaming it to operator callback because it's agnostic. We don't know what that operator is going to do. All right. Same thing as when we renamed that function here. We're renaming it here. Does that make more sense? That's where it's being called. Remember, anytime you have a function and you see parentheses, we are calling that function. Correct. What do you mean if I call the callback again? Which one? Not quite sure. Wait, if I on line 98, oh yeah, if I call it, is that what you mean? It's not a function, correct? Because divide is going to return something to us. If I call this function, it's going to return num1 divided by num2. If I don't add anything in here, it's going to say undefined, undefined, so it's going to return not a number, and we're going to get not a number for operator callback instead of a function. So we do not call the callback function right now. All right. We're going to use this stuff when we come back from this break. All right. Let's take 5. I'll see you in 5 minutes, and then we'll start using it. And you'll never stop using it as long as you write JavaScript. See you in 5. come on back. Let's start using these callback functions in a real way. Okay, I'm gonna just comment that out. And right now, we're gonna be talking about array methods. Array methods are, I want to say the kings of JavaScript, the kings and queens of JavaScript. They are everything, not everything. You're going to be using them every single day, okay? This is our first introduction to them. It might be your second or third. If you did all the pre-course work, we went over array methods as well. And hopefully you did your TK training. But let's just come through here and I'm going to grab a little bit of array data. And we're going to talk about it. All right. So remember that when we have an array, we can give it any data type. We can give it an object. We can give it another array if we wanted to. We can give it a string, a Boolean, number. We can give it a function if we wanted to. An array can take any data type in here. In this case, we are going to be using objects. So right now, tell me the most naive, simplest way to iterate over this array of data and to console log each item. Yeah, for loop, right? So let's go for let I equal 0, the standard array for loop city data dot length I plus plus. And then let's just say I want to console log each of these cities in here. How would I write that? I only want to do the city. So if I did this, that's actually going to think that city data itself is an object, and it's going to look for a city key. Okay, so we needed to do one more step. Yep, and you guys got it. Throw those brackets in there, and then put the I. So this is going to find that exact item in the city data, and it's going to log the city, right? So let's clear this. Let's run it. Run. I might be getting something funky. New function is not defined. Where am I? I'm just gonna 59. There we go. Should be, right? Okay, cool. So what I did was I went and got each item, right, using I in the city data, and I returned the city to it. Okay, so what would this look like if I wrote it as a function? What if I said function get city, right? And what this is going to do is it's going to take a city object, and it's just going to return city object dot city, right? It makes sense, right? So I can call this each time for that, right? What if I took get city and I put the city object in there? And so what this is going to do is it's going to take that city object and it's just going to return the city from it. Any questions on that? Should be pretty straightforward, and it's going to console log it. Questions? All I did was pass this object into it, and it's just going to, this is only one city, and it's just going to return that city to us. Whatever we pass into it. In this case, it's going to be each of these, right? We're going to iterate through this, and we're going to pass each of these objects into that city, get city. And then we know we can just return the city from it. So if I console log, if I run this, we should expect to see the same exact thing happen. It just passes our cities back to us. All right. Now let's take this one step further. Arrays have a number of built-in methods to them. The easiest, the first one to understand is called for each. And all for each does is creates a for loop, and it passes the individual item in to whatever callback we give it. So if I say city data.forEach, I'm going to give for each a callback. I'm going to call it get city. All right. Let's say I'm going to call this array item instead, so if that makes it a little bit easier for you to understand. For each, what for each does is this right here. It's going to take that callback, it's going to create a loop for us, and it's going to pass each individual item from that array into the callback. That's all it does. It doesn't return anything new to us. It doesn't do anything new for us. So I can clear that, run it, and we'll get the same exact thing. What if I do, instead of city, I say state? And there we go. Okay, so what for each does is it takes a callback as its only argument, and it iterates over, it creates a for loop over the array, and passes each of those items into that callback. So we have to understand that for each is going to have a specific pattern in our callback. We can write this callback any way we want, okay? For each does all of this for us. I'll just say this, it does all of this for us. We don't have to do anything about this. Instead of doing this, we simply do this now. Where's it at? Come on. Oh yeah, I got a console log here. Not return. And there we go. Okay, so it does all of that for us. We don't have to write any of that anymore. All we have to do is write for each. We give it a callback. A callback takes a single item from that array and it does something to that item. Okay, well, we can do something like this. Array item dot city, comma, and we can run that. All right, so all it does is creates a simple for loop for us. I'm going to keep moving through this. How does it know array item is part of your current array? Because we give it the array. We call this on the array specifically. Okay, so that's important. This array is going to have different items in it, or this array is going to have its own methods. Remember, this is called a method when we say dot and the name of the method. So this is the array, and we call it on the array. So it knows that this is going on that specific array. All right. For each is simple because for each just calls a callback and does nothing else. All right. Probably one of the more powerful array methods is called map. Now what map is going to do is it is going to run a for loop. It is going to pass that item, and let's actually get rid of that. It's going to pass that item into the callback. That callback is going to return something, and map is going to create a brand new array with that return data in it. Yep, perfect, Michael. So I'm going to create a new array here. And all I want to do is just give it 1, 2, 3, 4. And what I want to do here is I want to add one number to each of these. Okay. And I want to create a new array with those new numbers in it. So I'm going to show you something really crazy right now. I'm going to write my callback directly in the parameter here. I can do this anytime. I can do it. I could have done it right here. I can write this callback in there. This is not a map specific thing. I'm just writing the callback directly into there. All right. And what I'm going to do, it needs to take an item. So what this is going to do is this is going to do a for loop on our city data. It is going to pass each item into, oh, not sorry, nums array. I'll do nums array instead. It's going to pass each item into this callback, and we're going to return, we're just going to manipulate that item. All right. Yes. Yes, this is an inline function. The map is going to return a brand new array to us. I want to do a little bit of this. Let's get rid of that for a second. And then we are going to console log nums array. We're going to console log new array. Let's run it. I'm going to run it again. And now look at this. Clear it, and we'll see that our old array stays the same. We don't change our old array, but we have returned a new array with each of those items with 1 added to it. What if I said 100? I can do whatever I want to those numbers in my map. Okay, so this is going to iterate over the entire array. It's going to put a for loop on our nums array, and it's going to pass each item into this callback. It's going to take each item, put it in a new array, and give us back that new array. Questions right now? This is using callbacks in real life. When using map, we do have to put it in a new variable because it's going to give us back. Map itself is going to return a function for us. And actually, when I'm done with class today, I'm going to write all these out, and I'll give it back to you. And you can see how it's actually working behind the scenes. Can I nest functions in an array? Sure. I can return an array of functions. Yeah, I'll show you that right now. So let's go. Okay, let's go look at our city data, and let's say we wanted to map. We wanted to create a new array with only the city and the state, or maybe only the population in the land area, since we already did city and state. So let's do this. Let's go. City data. dot map. Let's go let new city array equal city data dot map. And I'm going to go function. What is the one? Well, there are multiple items, but for now, what's the one item our callback function takes? The array doesn't take the array, doesn't take the index. Let's look at line 122. Almost though. So it will give the index. For right now, it needs one item, and that's the individual item from the array, right? So I'm just going to call that array item for now. You can call that city object if you want. I'm going to call it array item. What I'm going to return is population array item dot population, and then land area. So what this is going to do is this is going to create a new object of just population and land area, include those two pieces, and return that object. This is a little more intense than adding 100 to a number, right? But we can see here that we're going to get a new array with just the things we asked for it. This is where map starts to get powerful. Look at that. Now we have just the land area and the population. Maybe we wanted anonymous data and we didn't want to know what the city and state were, so we can plug this into some machine learning algorithm or something. That's a little intense, but this is kind of what you're going to be doing on your project this afternoon. I want to move on to two other things. One of them is really intense. Not really intense, but quotes where, Daniel? If I put quotes around here, then we are going to get something completely different. Wait, quotes around the key? You don't need quotes around the key. You can if you want. It works. Same thing. Sure. Okay, I'm going to move on to filter right now. So filter is a cool one. And that it's going to take a callback, just like all the others, and it's going to determine whether the item passed into the callback is true or false. If it is true, it's going to put it in the new array. If it's false, it's not going to put it in the new array. So what if I wanted to filter by population? Okay, and I want to say I only want to know cities above 8 million. I think that's 8 million. Yeah, 8 million, right? I only want cities above 8 million. So I have this function, and I'm going to say return array item dot population greater than 8 million. So what this is going to do is it's going to take the array item, it's going to look at the population, and it's going to say, is this statement true or false? If it is true, it's going to take that array item and put it into a new array. If it's false, it's going to pass it. Array item does not become an object right now. Nope. Clear that. We're going to run it. And look, we only get one item. That's our New York. It's the only one that's above 8 million. Let's change this to say below 8 million. And now we get the other three, right? Because they are all under 8 million. And we can change this to say whatever we want. Let's say 500,000. There's only one city below 500,000. That's Kansas City. Okay. So filter and map each return new arrays. Map is going to return an array with whatever we return from the function, the callback function. Filter is going to return an array based on the truthiness of this statement. For arranged, you mean like in between? So if we can do, I mean, this is getting a little deeper than outside the scope of this lecture, but let's go. If below 500,000, return true. Else if this is fun. 8 million. Return true. Else return false. That'll be a range. Yep, that'll work. Let's clear that. We should get two cities, Kansas City and New York. Boom. There we go. We can use logical operators. We can use anything as long as this function returns a Boolean. It needs to return a true or a false. Okay. All right. I have a quick poll for you. I need to cover one more of these. I need 15 minutes for it. Do you mind if I go over 15 minutes? If you can't, that's totally fine. There will be a recording of this. I will have written much more of it out for you. I don't want to do a break right now. It's only been 30 minutes, and I need to cover this one thing. Otherwise, you guys can leave. I can keep recording, and then I can post this for you. I'm going over reduce right now. Yep. All right. I don't see any disagrees. I only see strongly agree or neutrals. So I'm going to do this over the next 15 minutes. This is a tough one. If this is your first time seeing reduce, I do not expect you to completely understand this. Okay. This is a difficult array method. Probably one of the most difficult things you'll learn as far as array methods go. But let me just say that once you fully grasp the idea of reduce, it is the most powerful thing in JavaScript. And in fact, map and reduce together are these two juggernauts of not only JavaScript but programming concepts. In fact, there are in complete data science ideas based only around map and reduce. Okay, so a short definition of reduce. What reduce is going to do is it's going to take an array and reduce it to a single item. Now, what does single item mean? Single item can mean I'm going to take an array of numbers and add them all up and return a single number. It can mean I'm going to take an array of objects and I'm going to add all the populations up and return a single number. It could be that I'm going to take an array of objects, I'm going to create a new object, I'm going to add all of the cities into an array and return that. So this single item, I don't want you to focus on this idea that it's one, primitive data type. So it's not going to be a single string. It could be a single string, a single number, a single Boolean. It could be that we're going to return a whole new array, and that's a single item, right? Or a whole new object, and that's a single item. For now, we're going to take it real easy, real slow. Let's use that nums array to talk about reduce. All right. This is the hardest part about reduce, is learning the signature, the reduce signature. So reduce is actually all of these other map, filter, for each have all taken one argument. What one argument has that been? What's been the one argument that all of those have taken? A callback function. And that callback function takes the array item, right? But map or filter only has one argument, right? That's one argument. That just so happens to be a callback function that takes an argument itself, but that's true. So reduce is going to be the same way. Reduce is going to take a callback as our first argument, and then it's going to take an optional starting point. The starting point is not necessary, but for right now, we're going to use the starting point of 0. Okay? So remember that reduce itself takes optionally 2 args. A callback and an optional starting point. Okay? Now, the tricky part comes in that this callback actually takes 2 arguments itself. Okay? This is definitely mushy brain time. So this takes what we call an accumulator and the current item. So we have to think of the accumulator as, I'll just show you. Okay. So what we want to do right here is we want to, let's say we want to return a sum of every number in this array. What we're going to do is we're going to return accumulator plus current item. I'm going to walk us through this right now. All right. Let's go. Sum equals that. Okay. So we're going to say console log sum. And you're going to be like, oh, what is going on here? But let's walk us through this right now. We have a starting point of 0. Reduce is going to do a for loop over our entire array. All right. It is going to take that starting point and pass it as the first item in that callback function. And then it is going to take the item in the array and pass it as the second item in that function. What we get returned from here will then be passed into it the next time as the accumulator and the current item. So let's do this. Let's console log the accumulator and let's console log the current item. We can see this. So we have nums array here, 1, 2, 3, 4. Let's just bring this down and we can kind of visualize it. We're going to know that it's going to, first time, it's going to pass 0 as the accumulator and 1 as the current item. We are going to return 0 plus 1, so we should get 1 as the accumulator next time and 2 as the current item. And it's going to go 1 plus 2, and we'll get 3 as the accumulator and 3 as the current item. We'll get 3 plus 3, and then we'll get 6 as the accumulator and 4 as the current item, and then we should console log 10 out. I can do that, that's fine. Okay, so let's run it. Let's see what happens. Ooh, I want to do that. All right, so let's step through this one at a time. First things first, the accumulator is 0. The first time this function is run, right? Because that's our starting point, is 0. And the current item is 1, okay? Because it's the first time through. Second time through, remember 0 plus 1, and that's what our accumulator is the next time. So we get 1, and the current item is 2, okay? Because it's the second item in the array. Third time through, the accumulator is 3, and the current item is 3, right? So it steps through this one piece at a time, and it returns whatever has been accumulated to it in the step before. And finally, in the end, we get the sum of 10. All right. Brief example of how I'd use it in the wild. Let's just do it. I'm going to write this out. First of all, what questions do you have right here? The callback function in reduce always takes 2 parameters. Okay? Always. And this is very important, the order that we pass these parameters in. The accumulator is always first. The current item is always second. All right? Remember that reduce also takes 2 arguments, the callback and the starting point. If we don't have the starting point, the accumulator is just the first number or the first item, and that first step is skipped. For now, let's have a starting point. Nope. Sufyan, it does not only work for number arrays, it works for any array. Remember, I pointed out, reduce takes an array and reduces it to a single item. Item can be the number, Boolean, array, object, function, etc. Right? It can be anything, and it can be done on any array. I'm doing a number right now because it's very easy to do this sum of numbers. Not very easy, but it's the easiest. Yep, we sure would. And that's because we skip the first step and go straight into the accumulator being the first item if we don't give it a second argument. So what happens if I do my starting argument as 100? Should see 110 come out, right? There we go. This is a really good example. The accumulator, when we put 100 in the first time, is 100. The current item is 1, right? We are returning the accumulator plus the current item, the accumulator plus the current item. So now, the second time, our accumulator is 101, and our current item is 2. 103, 3. 106, 4. 110 is the final, okay? Can you have an array of words and forms a sentence? Absolutely. Yes, you can. All right, this is just a little bit of oh man, reduce. We takes 2 things. I'm going to just give it 1 item here now, 1 argument. Remember, it's going to take the accumulator and the current item. Return accumulator plus a space plus current item. So now we should see a new sentence pop out. Oh, what the heck? We'll clear that. And there we go. We have taken an array of strings and we have created a single string out of it. Remember, reduces it to a single item. I could have started it with anything I wanted to. I could have started it with a string to make sure it was a string. So look at this, then I can go like that, and it will, or actually let's start it off at 10. And it'll make sure that it coerces it to a string. Crazy. So yeah, we could have done anything here. I just wanted to point out to you that reduce can take an array of anything and reduce it to anything. All right? Yeah, sure. Let's go right here. Let's run it. Okay, the accumulator right now is hello because we didn't give it a starting point, and the current item is my. Then we get hello my, and we have the name as the current item. And then we have the accumulator as hello my name, and the current item is. So just think of the accumulator as being all of the operations up until this point, okay? All of the operations that have happened up until this point is the hello my name. That's what the value is. And if we add is to it with a space, we get hello my name is. And then we add Dan to it with a space, and we get hello my name is Dan. Okay. Did I misspell something? Accumulator. I don't know. Let's Chris, I want to point out that for each does not return a new array. Reduce does not return a new array unless we ask it to. Map and filter return new arrays no matter what, and they never change the original. That's correct. Reduce is like, you can write every single one of these array methods using reduce. All right. Let's see. Does accumulator and current item be called anything? Let's just call it accumulator and current item for now. It doesn't have to be called this, but just for our understanding, let's call it this. Exactly, Lindsay. We're at 15 minutes. I'm going to throw down one real quick with city data. Sum of populations. We'll give it a function. So if I'm going to use something like an object in here, but I want to get a number returned, I need to specify that starting point. And I'm going to return is accumulated not with TCs? Oh, whatever. Accumulator plus current item dot population. So remember, our city data has a population, which is a number. I just wanted to add all the populations up. Just get the sum of the populations. So I'm going to say the accumulator plus the current item, which is an object, dot population. Okay? And I should get the sum. Oh, I got to console log that. Get rid of that as well. Run it. And that's the sum of all the populations of all the cities that we have. Okay. So let's talk, wait, why do we need to specify accumulator? Because we don't always just add something to the accumulator, right? We could do something else to it. We need this accumulator to, that's what we're reducing it to, right? Is this thing, and this is the piece of memory that holds all of our steps, okay? So we do need to specify it. Yeah, because what if I did this? What if I said if current item dot population is less than 8 million, then return accumulator plus current item dot population. Else, return accumulator minus current item dot population. This is, I don't know why you do this, but you can, right? So we're going to get all of the populations of all the other cities subtracted by the population of New York right now. And that's what it is, right? New York has 6,640,000 more residents than all those other cities combined. Okay, so look at what we can do to this. We can plug this huge data set in and boil it down to a single number of like, oh, this is the number I'm looking for. We can do this massive things with it. I don't want you to worry about like doing these multi-step things here. I really just want to worry about using reduce to return a single item. If you don't have a number, it's going to use the first item in the array. And in this case, that first item is going to be an object, and it's going to screw us up completely. All right. I'm going to end it here. I'm going to write some more code into here. I would like to show you how these things are working behind the scenes. Please go take lunch. There's going to be a recording of this. You're going to have some more stuff, and this is in training kit. Also, there's a take this as you will. There's this cool little animation thing I found. These are not correct. The accumulator and the value are in the wrong spot, but it kind of gives you a little visual of what's going on here. But thanks for hanging out with me an extra 20 minutes. I apologize for cutting into your break for your lunch. This is important stuff. Map especially is important. Reduce will, like, once you get it, will make your life like 10 times easier. But map is really important. We'll be using map a lot. And that's it. Have a great day, everyone, and I'll see you later.